Good day, everyone. We are the group assigned to present our statistical analysis about the average time spent on social media per day by the NBSC students. Social media has a big part of students' daily lives, and we wanted to understand how much time they usually spend on social media and how their usage differs from one another. As we go through our presentation, we will explain each computation step by step and discuss what the results mean in relation to the students' daily social media usage. Before we proceed, let me introduce myself first. I am Ramaria G. Balcusubagan, and in this study, we gathered data from 35 randomly selected NBSC students and applied different statistical tools such as mean, median, mode, range, variance, standard deviation, z-scores, and probability concepts. These statistical methods help us analyze the data and interpret the students' social media usage patterns more clearly. For letter A, we computed the measures of central tendency, which are the mean, median, and mode, to identify the average and most common time spent by NBSC students on social media each day. First, to get the mean. We added all 35 data values, which resulted in a total of 132 hours. Then divided it by the number of students, which is 35. Using the formula, we obtained a mean of 3.77 hours. This means that on average, NBSC students spend about 3.77 hours per day on social media. Next, we determined the median by arranging the data from lowest to highest and locating the middle value. Since there are 35 observations, the median is the 18th value in the ordered data, which is the 4 hours. This means that half of the students spend less than 4 hours on social media, while the other half spend more than 4 hours. Lastly, we identified the mode by finding the value that appears most frequently in the dataset. The value 5 occurred the most number of times, making 5 hours the mode. Therefore, the most common amount time spent on social media among the students is 5 hours per day. For letter B, we computed the measures of variability, which are the range, variance, and standard deviation, to determine how spread out the students' social media usage times are from one another. First, we calculated the range by subtracting the lowest value from the highest value in the data set. The highest record time was 7 hours while the lowest was 0.5 hours. So the range is 6.5 hours. This means that the difference between the student who spent the least amount of time and the student who spent the most amount of time on social media is 6.5 hours. Next, we computed the variance using the formula, where we subtracted the mean of 3.77 from each value, squared the results, added them all together, and divided by n-1 or 34. The computed variance is 3.56. This value represents the average squared distance of the data from the mean. Lastly, we calculated the standard deviation by taking the square root of the variance using the formula, which resulted in 1.89 hours. The standard deviation tells us that the student's daily social media usage usually differs from the average by about 1.89 hours. Overall, these measures show that the data are moderately spread out around the mean. For letter C, we determined the range of values that contains the middle 68% of the data using the empirical rule. This rule states that in a normal distribution, approximately 68% of the data falls within one standard deviation above and below the mean. From our previous calculations, the mean social media usage of the students is 3.77 hours, while the standard deviation is 1.89 hours. Using the formula, we subtracted the standard deviation from the mean to get the lower limit and added the standard deviation to the mean to get the upper limit. The lower limit is 3.77 minus 1.89 hours is equal to 1.88 hours, while the upper limit is 3.77 plus 1.89 hours is equal to 5.66 hours. Therefore, the middle 68% of the students spend approximately between 1.88 hours and 5.66 hours per day on social media. This means that most students' social media usage is concentrated within this interval, making it the typical range of daily usage among the respondents.
Good day everyone, I am Alvin Parista Oras and I will discuss the part D of dataset 5. My task is to compute the Z-score of 3 hours and 5.5 hours of social media usage and explain what these values indicate about their position relative to the mean. For letter D, we computed the Z-scores of 3 hours and 5.5 hours to determine how far these values are from the mean in terms of standard deviations. We use the formula where x is the given value and another is the mean and is the standard deviation. Using the mean of 3.77 hours and the standard deviations of 1.89 hours, we first calculated the Z-score of 3 hours. Substituting the values into the formula, we obtain a Z-score of approximately negative 0.41. This means that 3 hours is 0.41 standard deviation below the average social media usage of the students. Next, we calculated the Z-score of 5.5 hours and obtained approximately 0.92. This indicates that 5.5 hours is 0.92 standard deviations above the mean. In interpretation, negative Z-scores represent values below the mean, while the positive Z-scores represent values above the mean. Therefore, students who spend 3 hours on social media is used to slightly less than the average student, while those who spend 5.5 hours use it more than the average.
So good day everyone, I'm Victor Timunja. So our part is to determine the dataset 5. So my part is to discuss what values belong to the 20% and the bottom of 10% of the data. For letter A, we determine the values that belong to the top of 20% and the bottom of 10% of the data using the J table, the normal distribution formula. The top 20% refers to the student who spend more time on social media compared to the most of the respondents, while the bottom 10% refers to the students who spend the less amount of time. First, for the top 20%, we look for the Z-score corresponding to an area of 0.80 in the Z table, which is approximately Z is equals to 0.84. Using the formula with the mean of 3.77 hours and a standard deviation of 1.89 hours, we substitute the values and we obtain the x equals to 5.35 hours. This means that students who spend about 5.36 hours or more on social media belongs to the top 20% of users. Next, for the bottom 10%, we located the Z-score corresponding to an area of 0.10 in the Z table, which is approximately Z is equal to negative 1.28. Substituting the values into the same formula, we obtain x equals to 1.35 hours. This means that students who spend about 1.35 hours or less on social media belong to the bottom of 10% of the users. Overall, this result will help identify students of unusually high and unusually low social media usage compared to the rest of the group.
Good day everyone, I'm Rainier A. Villanueva and I was assigned to discuss the part F of dataset 5. For letter F, we determine the proportion of students who spend 2 hours or less on social media in a day using the Z-score formula and the Z-table. First, we identify the given value x equal to the mean of 3.77 hours and the standard deviation of 1.89 hours. Using the formula, we substitute the values and obtain a z-score of approximately negative 0.94. After getting the z-score, we refer to the z-table to find the area to the left of 7 equal negative 0.94. The table shows an area of 0.1736 or 17.36%. This means that approximately 17.36% of the students are expected to spend 2 hours or less on social media per day based on the normal distribution model. In interpretation, this indicates that only a small portion of the students spend a relatively low amount of time on social media compared to the overall average usage of the group.
Good day everyone, I am Jimart G. Delmar and I am assigned to discuss the part G of dataset 5, which is what is the probability that a randomly selected student spend 5 hours or more than on social media per day. After G, we are asked to determine the probability that a randomly selected student spends 5 hours or more on social media per day using the Z table. First, we compute the z-score using the formula where x is equals to 5. The mean is 3.77 and the standard deviation is h is equals to 1.89. Substituting the values, we get approximately z equals 0.65. Next, we refer to the z table to find the area to the left of z equals 0.65, which is 0.7422. However, since we are looking for the probability of students spending 5 hours or more, we take the complement by subtracting from 1. So 1 minus 0.7422 is equals to 0.2578. This means that there is about 25.78% probability that a randomly selected student spends 5 hours or more on social media per day.
So, hi everyone, my name is Marvin Logroño. For letter H, we are asked to determine the approximate number of hours a student spends on social media. Spends on social media per day given a z-score of 1.25. To solve this, we use the formula 3.77 represents the mean, s is equal to 1.89 is the standard deviation, and z is equal to 1.25. Substituting the value, we compute x is equal to 3.77 plus 1.25, 1.89, multiplying first 1.25, 1.89 is equal to 2.56, and then adding it to the mean gives x is equal to 3.77 plus 2.36 is equal to 6.13. Therefore, the resulting value is approximately 6.13 hours. This means that a student with a z-score of a 1.25 spends about 16.13 hours per day on social media, which is higher than the average usage time, indicating above average social media consumption compared to other students.
Based on our analysis, most students spend several hours on social media each day, with the majority falling within the typical range that we computed using the empirical rule. These results show how statistics can help us better understand trends and behaviors within a group. We hope that through this presentation, everyone will gain a better understanding of how statistics can be applied in real-life situations and how data can help us interpret human behavior and daily activities. Overall, this activity allowed us not only to practice statistical computations, but also to appreciate the importance of statistics in interpreting real-life data and making meaningful conclusions. Thank you for listening, and we hope you learned something from our presentation.